All right, here's domain and range for two different square root functions that look similar but give very different answers for those portions. So we'll start with the one on the left, the f of x equals square root of 9 minus x squared. Anytime you work with a square root, you need the quantity underneath to be non-negative. So we're going to set that quantity greater than or equal to 0. When we solve that for x, we get that x squared is less than or equal to 9, and that means all squares of number that will be less than or equal to 9, with square root 9 you get the plus and minus 3, but we need it to stay in between negative 3 and 3 for values in order to work for this function. Okay, with that domain being said, when we go to look at range, you are restricted between negative 3 and 3. At negative 3, the range value would be 0. At positive 3, the output value would be 0, right? 9 minus 3 squared or 9 minus negative 3 squared. Either way, you square root 0. So what happens in between is going to sort of help set the range. So the closer you get to 0, like negative 2 or 1.5 or half or 0.01, the value that's under that square root, the x squared portion anyway, gets closer and closer to 0, and then that means you'll take 9 and subtract a smaller and smaller number. So in reality, the smallest that x squared could be in this range is 0, in order to give the largest number under the radical. And when you put a 0 in there, you get the square root of 9, which is 3. And so the range for this problem actually ends up being every number that is in between 0 and 3. So if algebraically that doesn't quite jive, you're welcome to go to the graph for this one. And the graph for this one would look, it's a semicircle, the top half of a semicircle, square root of 9 minus x squared. And you can see the graph on the x-axis bounces between negative 3 and 3, and it doesn't even start until the horizontal axis of y equals 0, and it runs up to the y value of 3 for its highest point in this curve. So your range for this function only goes from 0 to 3, and it can be 0 and it can be 3. So that's why we say the range is in between 0 and 3 with the less than or equal to signs. For the second function, the g of x function, it's a little different. You still set the quantity that's under the radical greater than or equal to 0. You get x squared minus 9 greater than or equal to 0, x squared greater than or equal to 9. But now you need for those squares to be greater than or equal to 9. So you can square root and get plus or minus 3, but instead of being in between negative 3 and 3, it's going to be all x values below negative 3 and all x values greater than or equal to 3. And you can go and look at this on the graph and see that that's what happens here. They're like little square root functions that shoot off to the left and the right, and they don't start until 3 and negative 3 on the x-axis. So then we go back to the function. There's our domain. X is less than or equal to negative 3, and x is greater than 3. And when we start to talk about the range, again, thinking about all the possible outputs this function could give you, there'll never be a negative output. So at minimum, it'll be positive things. It could potentially be 0 if it were 3 or negative 3, but it'll always be positive. And because you can do at 3 and negative 3, and it can be 0, your range will start at 0 and go everything above it. And you can see that from the graph as well. You know, zoom out and those curves just continue forever. They don't really have any sort of leveling off point like power functions tend to get or logistic. So for this problem, we have the domain is x is less than or equal to negative 3, or x is greater than or equal to 3, and the range is all function values, which in this case was g of x, greater than or equal to 0.